Hello again. This is another update video, and I'm basically showing progress from this week and last week. Um, but basically the mods that we were using, we tried to get a multiplayer mod, but it didn't work, and then we started building with it. We started building with the mod installed, which we shouldn't have. And basically that led to just like mods not saving all of our boards and our worlds and stuff, and they got all corrupted, so now it deleted everything, which really bummed us out. But it gave us a chance to rebuild some things since we had more knowledge about them. So I didn't get to record a video on it, but I built an ALU that had that was okay. It was on a 70 by 70 board, and it was decent. But when it got deleted, I was really sad. But then I built a new one, which is on a 50 by 50 board. And this one is like half the file size and much more compact and just more versatile than the other one. And I'll just show you different functions and that kind of thing. So here's the opcode selector, and here are the flags. So the different flags here, well, flags basically just tell the computer like what's like the status of the ALU. So like if the output is even, if the output is odd, if there's overflow, if there's carry 1 bit, if the answer is negative, or if the answer is 0, which it is right now, and it also is even, because a binary number is only odd when this first bit is on, because this technically represents a 1. So that's how I detect if it's even or odd. So the first opcode is just all zeros that just add. So I can add any number, so like 1 plus 1 here, and that gives us 2, like it should. And, oh yeah, I'll show you inside. So here I stacked a decoder on 2 separate boards, and this decoder handles the opcodes. Basically, it turns on different circuits for different operations. And under here, you can't really see it, but I have the CLA adder component under here, which makes the ALU super fast. And I tried to use as little blotters as possible, and inverters too, so. Okay, so I'll show you subtract now. That's just 0, 0, 0, 1. And here's subtract, so we did 1 minus 1, that's 0. So I'll show you just 2 minus 1, and that's just 1. And I didn't put the output at the front just because in the main scheme of things, we're going to put the ALU here, and then the control unit right here, and then these directly go to these like outputs directly go to the control unit, and then this output goes onto the big bus. So that's why I just put it on the other side, and these things like strategically on that side. Yeah. So next function is increment. That just adds 1. Yeah, just adds 1 to any number that's in there. And negate, so, well, negate A specifically. Basically, that just inverts all the bits. So remember this pattern. Basically, when we go over to the other side, this last bit should be on, and every bit that is off, every light that is off here should be on the other side, and every bit that is on here should be off. And yes, that is the case. You also have negate B. It just does the same exact thing, but for the B input over there, so I'm not going to show it. And we also have AND. Let's opcode that. So ANDing, it just ANDs bitwise with 2 numbers. So it won't show up unless the other corresponding bit is on. So then the output shows that. And we have OR, which is 111. It just ORs numbers, so it doesn't, carries are not included, it just ORs numbers regardless. We also have XOR. And that just XORs numbers, so it's on, but when you turn the other corresponding bit on, it's off, but there's no carry, which is good. And rotate right. Basically, bitwise rotating is if you have a bit that is on over here. Basically, what rotating left or right is this light will turn off and it'll like move over to this other lamp or whatever. And then if it's rotate left, this will move over to there. And with rotating, the bit isn't lost when it's here and it rotates out over there. It actually goes around to the most significant bit. So it doesn't just get lost. Same thing for this one. If this rotates left over to the side here, it won't just disappear. It'll go around over to here. And I'll show you that. So we have 1 here, and we rotate this. Oh wait, no. I'll show A first. So if we rotate this to the left, and that is this, you see it rotates to the left one. But if we rotate it to the right, it'll become the first one. See, it like went from here to all the way over here. And it's the same thing for B too. And yep, that's it. So, hope you had fun watching my video. See you next time.